Okay, so for starters, if we want to evaluate a formula, or if we're like given a formula, what we do is, let me get an example. So we could be given a formula like we see in example one. To evaluate, what we do is we plug in the pieces of information that we are given and we solve for the remaining term. And if it's evaluated, technically what we're going to do is just plug things on one side and we don't really have to do any algebra to solve for the other side. And so a little bit of a note that I put in between example one and that process is that when we are multiplying and we are dealing with variables now, there's a lot of different ways to write multiplication. We can see the classic case of A dot B, or we can see a parentheses around our A, B, or we can just write the letters immediately next to each other. All of those mean multiplication. So when we see this question down here, what it's saying is that we're doing d squared times n over 2.5. And if we're evaluating, we have to have some information. We have to know what, in this case, I think I wanted d. We're trying to find our r. Let's say our d is 3 3/4 inches and our n is equal to 4. So I'm going to plug those pieces of information into my formula. So many things are wrong with this. Okay, so we're moving into chapter 7. Chapter 7 is going to be kind of building up to more complex word problems. So the first one or two sections are really going to focus on the building blocks, the foundation, and then we will build into those more complex examples. So for starters, evaluating formula is kind of the simplest word problem you'll see in this course. Is generally we're given something like this equation. Let's see in example one. We're given something where we have a lot of variables in it, and we're going to want to solve for our r. And we do that by plugging in things for the variables, like we're going to be given a d and an n in that case, and then we're going to use order of operations to solve. One little side note before we go through that example is that when we are dealing with multiplication and we bring variables into play, there's a lot of different ways to write multiplication. We can see the classic a dot b. We can see the parentheses around a, b, that's multiplication, or the parentheses around b next to a, or we can just see the letters written next to each other. All of those mean multiplication. So in this problem, we're given that the automotive engineers use the following formula to find the SAE rating of an engine. We're going to call it R just to label it as a variable. So we're given that my D is going to be 3 3/4 of an inch, and my N is going to be 4. So I plug those guys into my formula. 3.75 squared times 4 divided by 2.5 following order of operations, I will get 22.5. And you'll notice how I really didn't talk about anything that involved the SAE rating, which is if they give you the variables straight up like that, then you don't really have to know much about the equation. All you have to do is plug in and solve. Okay, temperature conversions. You probably have seen these equations before somewhere. We're going to get, instead of kind of just saying they are the same thing or they're not the same thing or they're heavily related, we're going to use one equation to solve for the other one. So this is one of the equations I had on my last slide. C is equal to 5/9 feet minus 32. And with conversions, we should be able to go back and forth and get a similar result, like we had with the millimeters to inches and the inches to millimeters, or is it feet to, I think it was inches to millimeters. You should get the same result. Same thing here is that I have this equation. I'm going to solve for the other equation, and by doing that, I'm going to get f by itself. So I multiply both sides by 9/5. I add 32 to both sides. I'm left with my Fahrenheit being equal to 9/5 centimeters plus 32. And that's, I don't know, it's a simple derivation. I wouldn't really linger on it too much, but that's the idea, is that if you have a formula, you should be able to kind of solve backwards and get the other formula. But this is more kind of the speed that we're looking for. We're going to take a patient's temperature and we're going to convert it. So this is a great application question. It says know a patient's temperature is 40 degrees Celsius. And I don't know about you guys, but that doesn't really mean anything to me. I know that in Fahrenheit, 98 point, I want to say 6 or in that area is the standard human temperature. So if I had it in Fahrenheit, I could make a fair comparison and say, okay, we should be worried about this or we shouldn't, or that's normal. So I'm going to take my formula that I have in the bottom left of the screen. I'm just going to plug in 40 in for C. Since I'm dealing with fractions, I do 40 over 1, multiply straight across. I'm left with a Fahrenheit temperature of 104 degrees Fahrenheit. And so you might be saying this doesn't feel like a conversion. There's no dimensional analysis. There's no shifting of decimal places. And that's true, but we can do conversions with straight up formulas. Or like we saw with board feet, sometimes you just plug it in and you're good to go. So that's the way it is with temperature as well, is that there's a very strict kind of formula that converts from one to the other. And so we're not super concerned about the units as much as just making sure we use the formula correctly. Okay. Now, as a conclusion, 140 degrees Fahrenheit. I know that is not the standard temperature for the human body. I've had nurses in my classes before, and I think the consensus was essentially that is a high temperature. That is not a grab the ambulance and get to the hospital immediately temperature. So it's something, if you see that, you should be concerned. You should start kind of going through some home remedies, resting and all. So some important things to be aware of when we're approaching these algebra problems, these word problems, is what are like terms, what are unlike terms. I'm going to pull up all of them at once. So a like term is that if you have the same variable with the same power, then you consider that a like term. So x squared and 2x squared. Yes, I have a 2 in front of one of those, but they are like terms because they both have x's, they're both to the second power. Same thing with the bottom left. Xy to the third, xy to the third, same thing. They're like terms. Also, if I have no variables, so if I just have two numbers like 2 and 3, those are considered like terms. Why those are important is that when we get into the adding and subtracting of things, we should be able to combine like terms. We cannot combine unlike terms. So those are things that are either they don't have the same variables, they don't have the same powers, or they don't have the same variables to the same amount of powers. That last case I'm kind of mentioning, if you look in the second example on unlike terms, yes, I have a power to the third, yes, I have a power to the first, but the x to the third, my first term has x to the third, my second term has y to the third, so those are not like terms. X squared and x, those are different powers, they are not like terms. And then the last example, 2y and 2x have different letters, so those are not like terms. So to kind of dive into an example, here I have both of these separate terms have a y, they have a power to the first, so they're like terms. And when I have like terms, I can combine them by just doing basic addition of the numbers. So 5y plus 10y is going to be 15y. And then I just kind of carry over the number. So if I'm adding and subtracting, I'm not really going to be changing the variables at all. I'm only going to be changing the numbers in front of them, which are called coefficients. So again, in this case, I have like terms. I'm subtracting, so I'm going to do 7 minus 3 will get me 4. And then I copy over the like terms, xy squared. Now this one's meant to be a little bit tricky. I have 3 terms here. But notice how only 2 of them are like terms, the 2x and the single x. So I can combine those, but I can't do anything to the 5xy. So I'll combine my 2x, I'll subtract an x, that leaves me with 1x, or just x. And then I just have to kind of carry over. I bring over the 5xy, I can't go any further, and that's my final answer. Kind of taking that to the nth degree in this last question, I have a lot of things flying around, a lot of terms. Let's see if I circle things. I did not. So instead I kind of look at the individual pieces and say, let's start with the y. Okay, well I have 5y, I have minus 2y, I have a positive 1y. So if I combine those 3 things, 5 minus 2 is 3, plus 1 gets me 4, so I'll have 4y in my answer. And then I do the same thing for my x's. So it's minus 6x plus 7x. Well, 7x plus x gets me 8x, minus 6x gets me 2x, and so those two separate things are my result. And if I had this on pen and paper, I honestly probably would circle things or underline them, because, yeah, you can actually get very lengthy expressions, and so it's a good idea to kind of do something to keep track of what you're doing. I've seen people kind of cross things out, and that's an okay method, but if you make a mistake, it's kind of hard to go back to the problem and see what you actually crossed out. So I recommend kind of underlining or circling things. Okay, I guess that kind of jumped the gun on that thing. We'll come to the note there shortly. But if we're adding and subtracting entire expressions, well, if we're doing addition, really that doesn't really affect a whole lot. You would treat it as though you would have the first three terms being added to the last two terms, which if you did that separately, that's the same thing as just adding the entire thing. So you just basically remove the parentheses and then kind of fall back to what we did on the last slide of saying, okay, I have 3x plus x gets me 4x. I have negative 5y plus y gets me negative 4y. And I have a leftover 2xy. And it's worth mentioning, I may have mentioned on the last slide, if you have nothing in front of your x or your y's, there's kind of that invisible one. So that's kind of where I'm getting that 3x plus x gets me 4x. But what we have to watch for is if we are subtracting, we can't just drop all of the parentheses and call it good. What we need to do is we need to distribute the negative to all of the terms in the second parentheses. So what I mean by that is I'm going to change the sign of the x, so it'll become a negative x. I'm going to change the sign of my negative y, it'll become a positive y. And then I'm going to change the sign of my positive 3xy to make it negative. And so I'm going to rewrite my problem. And now that I've distributed all of those negatives, I'm actually set. Now I can kind of, I'm dealt with the second parentheses. I'm going to almost treat it as though I was doing the example A, in that I can drop all of my parentheses and kind of fall back to that idea of combining like terms. So it'll be 3x minus x gets me 2x, negative 5y plus y gets me 4y, 2xy minus 3xy gets me negative 1xy or negative xy. And so if I haven't talked about distributive property already, then what I'm doing there, that arrow trick that I kind of distributed the negative to the first term, the second term, and the third term. I'm still taking math courses to this day, and I use that. That's a good way for me to kind of keep track of how I am multiplying out, distributing things in front of parentheses. So I would recommend kind of sticking to that. It's a good way to remember that you've done it to every term correctly. Okay, if we don't have a negative in front, what we do is we're going to distribute whatever is in front into that parentheses. And then once we've done that, that's when we kind of, what the note was there ahead of time, that's when we kind of fall back to the combining like terms, being able to just add or subtract. So in this case, we're going to do negative 2 times x, negative 2 times negative 3y, so that I'll rewrite my problem as negative 2x plus 6y. My first thing doesn't change at all because there's nothing in front of them. And now I can just go ahead and combine like terms. 3x minus 2x gets me x. 2y plus 6y gets me 8y. So in this case, I have something in front of both parentheses, so I'm going to have to distribute. And it might be helpful to kind of distribute one thing at a time. If you're good at the distributive property, you can do it. You can do both things at once. That's fine. But at the end of the day, you're going to want to have something like in the previous example that no longer has parentheses. So for the first parentheses, if we distribute, I would get 4x plus 4y. In the second parentheses, if I distribute, I would get negative 3x plus 3y. So then I can rewrite my problem like this, and then again, I combine like terms, leaving me with x plus 7y. All that, if that remains for a while, that is a hospital visit.